The navigation screen at Mission Control shows a perfect orbit, but the spacecraft is already falling into Mars. No alarm triggers, no warning light changes. At NASA's Jet Propulsion Laboratory, engineers watch a clean trajectory line cut smoothly around the planet, even as the real spacecraft drops deeper into the atmosphere every second. The Mars Climate Orbiter was not supposed to behave like this. Its final approach burn, a routine correction before orbital insertion, had been calculated for months. Every system agrees. Every model confirms the path. And yet, the visual anchor on the screen, the predicted orbit line, is already intersecting the planet's surface grid. Quietly, precisely, fatally. This is where the contradiction begins. A trajectory that is mathematically perfect on paper is physically wrong in space, and no system flags it. NASA mission controllers trust the display because it has never lied before. The numbers are consistent. The simulations match. But consistency is not survival. The spacecraft continues forward, locked into a path that looks stable only because the system describing it is missing something fundamental. The visual anchor stays on screen, a clean arc looping Mars. But with each update, that arc sinks lower, cutting closer to the surface. And still, nothing breaks the rules. Months earlier, everything looked normal. The spacecraft received thrust commands, adjusted its course, and corrected its drift. The interface between navigation software and propulsion data stream appeared stable. But hidden inside that interface was a dependency no one questioned. One system reported force in pound seconds, another interpreted it in Newton seconds. Both sides stayed internally correct. That mismatch did not create noise. It created agreement. False agreement. At first, the difference was invisible. A tiny drift in trajectory, too small to matter. The visual anchor still looked safe. But space does not forget direction. Every correction stacked on the last error. Back at Mission Control, engineers saw nothing wrong. The prediction model still matched incoming telemetry. That was the trap. The system was not broken. It was consistent. And consistency hid the dependency. The first time the anomaly became visible was not through alarm, but through geometry. The orbit line on the display no longer cleared Mars cleanly. It intersected it by a margin so small it looked like a rendering glitch. That moment should have triggered doubt. Instead, it was dismissed as noise. But the next pass changed that interpretation. The visual anchor returned again. Same orbit line, same predicted path, but now the intersection was deeper. The spacecraft was not missing Mars. It was arriving inside it. And still, no system contradicted the model. The hidden dependency had already taken control. Every navigation update depended on the same flawed interface assumption. Thruster data flowed cleanly through the system, converted, recalculated, and revalidated. Nothing looked broken because every layer agreed with the layer above it. That is what made it dangerous. At mid-mission, a full-scale review was run. Engineers checked propulsion logs, guidance equations, and navigation outputs. Everything balanced. The mathematics held. But balance is not truth when the units are incompatible. A second visual anchor appeared in reconstruction, a clean orbital loop collapsing into Mars's surface grid. That image became harder to ignore than any report. Still, the system did not correct itself, because it could not see outside its own agreement. As the spacecraft approached final insertion, the dependency became unavoidable. The navigation system no longer had time to compensate. Each correction burn assumed the same flawed conversion. Each adjustment tightened the descent. Mission Control saw the trajectory tighten into a perfect curve. Too perfect. That was the last warning no one trusted. The visual anchor now showed a stable orbit line fully embedded in the planet. No gap, no escape arc, just a clean mathematical path into impact. Then the burn executed. The final correction was received and processed exactly as designed. Thrusters fired according to the converted values. The system confirmed success. On every screen, the spacecraft was healthy. But in physical space, it dropped into Mars's atmosphere. The signal degraded, then stopped. The hidden dependency had completed its arc. A single mismatch in unit definition had remained invisible because every system trusted the interface between them. No alarms existed for agreement, only for failure. The last reconstruction shows the orbit line one final time. It is still smooth, still perfect, still wrong. It curves into Mars as if that was always the plan. Because, in a way, it was. The spacecraft did not fail in a moment. It followed a path that was correct in every system that described it. And that is the final contradiction. The most accurate model was the one that killed it. One missing unit definition did not break the system. It defined the system. And long after the signal is gone, engineers still return to that screen. The visual anchor does not change. The orbit line is still there, still clean, still descending where no one meant it to go. Every review, every reconstruction, every correction begins and ends with the same image. Not because it is confusing, because it is too consistent to doubt. That is what makes it harder each time to look at it and not see what was missing from the start.